Hello, math students. Again, today we're going to take a look at a new formula for volume. We're going to be working with the volume of a cone today. The volume formula for a cone is very similar to the cylinder formula that we just worked on yesterday. And I would expect that probably you know what a cone looks like. It's got a circle base, just like the cylinder did. But instead of having two parallel circles for bases, there's only one base, and it comes to a point. So this is the typical kind of cylinder that you'll see. Sometimes when you get into geometry, they have different cylinders or different cones where the vertex, the very top point, isn't right in the center. But we're not going to have any problems like that. However, still you can notice in this picture, the area of the base has that capital B because that is still using the area of a circle as a formula. So it's going to be pi r squared is what's going to go in place of the B in our formula. And we have a height. Now here's the thing about cones versus cylinders. They don't hold as much. The volume is less. And in fact, it's a fraction of what the cylinder would be. So if I didn't have this 1/3 right here, this would be the exact formula that we used yesterday for the volume of a cylinder. For a cone holds 1/3 as much as a cylinder. So if we would have a cone and a cylinder, same area of the circle, same height, it would take 3 cones filled with, let's say, water, for instance, to fill up the cylinder that has the same dimensions. So when we're doing these kind of problems, that 1/3 in there, I know can cause a little bit of an issue for some students. Some of you have calculators that deal with fractions and some of you don't. I have a way to do this that I actually don't even use the fraction part of it. I have another way of typing this into my calculator that I feel is faster. But you can absolutely just take your volume of the cylinder that would match and multiply by 1/3, and that would get you the cone. The way that I do this, instead of multiplying by 1/3, I divide by 3. It's the same thing. If it's taking 1/3 of that volume, that's taking the volume and dividing it by 3. I would prefer on my calculator to just hit divide by 3 instead of multiply 1 fraction 3. It's faster. So here we are rounding to the nearest tenth with the volume of this cone. So just like yesterday, I'm going to suggest that we start by writing out our formula. The volume of a cone is going to be 1/3 pi r squared h. I'm even going to show you in a second a different way to write that same thing that you might see in other places. Let's just substitute in our numbers. So we're going to have v equals 1/3, and the pi just stays there. The radius is 6 squared, and then the height is 15. Now, those of you that like to do some math in your head, you might be trying to do some stuff with simplifying right now, like let's multiply the 1/3 by one of the other numbers. If you wanted to multiply with the 1/3 with the 15 or do some canceling, you can absolutely do that, and I do that. You cannot, however, use the 1/3 with the 6 because the 6 order of operations has to get squared before I can do any other multiplying, which is really what that canceling kind of thing would be. Or again, since we know it's going to be a messy kind of an answer, you can just type the whole thing into your calculator. And as I said in the last lesson, you need to be the smart one in this relationship. You can, if you know how to, just type this in straight across on your calculator. Personally, I would do the 6 squared, and I usually do that in my head if I can. That's 36. So I'll have 36. I'm going to multiply by the 15, and then I'm going to multiply by the pi. So it's exactly like yesterday. If you want to, you can even hit equals right now. You don't have to. And then you can either multiply by 1/3 using your fraction key on your calculator, or like I said, I prefer to just divide by 3. So I've got all that stuff in my calculator. I'm going to hit divide by 3, and I get this for an answer. I hope that you did that on your calculator as well, so you can check to see if you agree. So I'm going to write out a whole bunch of, that's what I see on my calculator. We're rounding to the nearest tenth, which is this place right here. That 8 is going to be enough to make that bump up. So my answer is going to be, and I should have had squiggly equal signs above also, 565.5. This is measured in centimeters, so this will be cubic centimeters. Okay. The other way to write this formula that I said I would show you, instead of that 1/3, some people do the same thing that we do for a cylinder, and then instead of the 1/3, they do, like I said, I do on my calculator, just divide by 3. You can write it like that. Really, all that did was take all of this part of the formula and like put it over a 1 to make it look like a fraction, and then I can smush all that together into one gigantic fraction. It's totally up to you. If you want to write it either way, I'm fine with. I will totally understand both of those ways to write it. Okay, so we've got a couple of examples here. And as I said yesterday, the problems like number 3 you can see right now is the diameter. Those are the tricky ones. I do want to go through one that's just a regular problem where they give me a radius, again, before I jump to the diameter kind of problems. Let's do number 1. It's going to give us a little bit bigger numbers. So my volume is going to be 1/3 pi r squared h. 1/3 pi. The radius is 9, so it'll be 9 squared, and then the h, the height, is 16. Again, personally, 9 squared, I'm not going to type that into a calculator. I know that's 81. I would just start on my calculator with 81 times the 16, and then I'm going to multiply it by pi. And then either multiply by 1/3 or divide by 3. I get that my volume is about 1357.168, blah, blah, blah. It's going to keep on going. So does this say a 1 or does it go up to a 2? That 6 is going to be big enough that should round it up to a 0.2 for my decimal. So 1357.2 cubic meters. Volume is cubic because it's 3-dimensional. Let's actually do number 4. Number 4 is harder than number 3. I hope you understand why. The radius on number 3 would be 8. And I know that in our formula, when we square the radius, you can just do 8 squared. That's 64. That's no big deal. However, in number 4, the diameter is 11 yards. That means that my radius is going to be half of that, or 5.5 yards. So this one is going to be harder to just do in your head. That's why I'm picking this one. V equals pi. Oh, I forgot my 1/3. 1/3 pi r squared h. So 1/3 times pi, the radius is 5.5. I'm going to put this in parentheses. You don't need to. I just think that sometimes when there's decimals in there, it gets a little bit confusing if I don't have parentheses. And the height is 14. Now, the 5.5 squared, you can either use your square button or you can just do 5.5 times 5.5 times 14 times pi, and then divide by 3. I have for an answer 443.488, blah, blah, blah. So is that going to stay a 4 or does it round up to a 5? In this case, because there's an 8 after it, that's going to round it up to be a 5. So 443.5 cubic yards. Now the answer that they have here looks a little bit messy, and when I have done this problem in the past, I just didn't choose to do it this way with you. That 5.5, they could make that 11/2. And when they did that 11/2, that's what would give them that fraction, and they can do some simplifying, but it'll still end up with the or with that fraction if you left it in terms of pi. Today, you have a worksheet. It's volumes of cones. Again, I'm going to say write down 3 lines of work for every problem. Write down the formula, substitute, and then get your answer. Make sure that you're rounding correctly. The answer key is in Schoology, so please check it. And then when you're all done with that, make sure that you do the knowledge check in Schoology. If you have any questions, let me know.